So one of the reasons we needed to talk about the structure of an atom was to make sure we were all kind of on the same track, that electrons are like out here, okay? So honestly, remember that we have the solid part with the protons and the neutrons in the nucleus of an atom, and then we have electrons out here. And as it turns out, the electrons around a given atom can do some interesting things that can actually give us clues as to the identity of what element that atom is. It's a wonderful thing. So, and this is not like just a strange sort of phenomenon that doesn't touch us in our everyday lives. Honestly, for instance, when we turn on a light, that there's in that light bulb there is a gas. And now we've got some kind of interesting sort of chemistries that go on with regard to light bulbs. But in general, that the electrons around the atoms of gas, okay, get excited because of the electricity that you are sending through that light bulb. And then as the electrons get excited, this is talking about energy states. A lot of times I'll say it goes to a higher energy state. Electron gets a higher energy state, okay? And then because of electricity, and when it falls back down, it emits a certain amount of energy. And that's what we count on as seeing that light. So light bulbs are all about basically electrons being excited and falling back down and giving us that energy, okay? So, but when we talk about it here in astronomy, I need to kind of get away from the whole light bulb thing and kind of talk about elements that are not like the matter that fills a light bulb. Okay, I said that we can actually use what electrons are doing to understand what element an atom is. So I have a link down here. It says flame test. I'm not going to go to it, but I have pushed out for this chapter kind of a cool something we do in chemistry sometimes, series of flame tests. And if you're familiar with this, basically you take a substance like sodium, different salts of sodium, aluminum, basically different elements, and you put them in a flame, like regularly like fire flame, and they will burn different colors. And it's all about the electrons around the atoms, okay, of that element. Ooh, next. Okay. So Kirchhoff came up with, there are three of Kirchhoff's laws. And these all have to do with basically kind of electrons, okay? What are electrons doing? Kirchhoff's first law actually gives us what's called a continuous spectrum. Continuous spectrum, I kind of kid, that's like the most boring type of spectrum. This sort of continuous spectrum, though, we're going to talk in the next section, where depending upon kind of how this energy is, okay, it has no lines, I have no blips to show me what electrons are doing, but I can use this continuous spectrum to know what the temperature of an object is. Isn't that fun? You don't have to visit the star, we can look at its continuous spectrum. Now, we have two, and they're kind of like emission line spectra and absorption line spectra. Now, they're kind of like inverted images of each other, or kind of negative images of each other, if you're kind of familiar with kind of getting a negative of a photo and a positive of a photo. So these are actually lines, discrete lines, okay, emission line, absorption line. These are lines that at a certain energy associated with energy that's either been given up there, if they're emission lines, or energies that's been taken from there, if they're absorption line spectra. And those given up or taken, okay, are all characteristic of a particular element. So basically, you go to your library, you get a line spectra. You go to your library and match up which element it is. Basically, these days you use a computer, but that's kind of what we do with spectra coming in from distant stars. So, emission line spectra. Here's the deal. Emission means emit, and so kind of like I talked about your light bulbs, kind of think emission line and light bulbs, that would probably work. Because basically, these are electrons that are emitting energy, this particular wavelengths, as the electrons fall back down, okay, to what we call their ground state. Okay, so they've been excited, and we'll have to talk about how they're excited, but when they fall back down, energy is emitted. Absorption lines, and like I said, if you're dealing with the same element, I'm going to show you some examples of these, they would have the same set of emission lines, they would have a similar set of absorption lines for that given element at the same energies. And kind of as I kind of going across the kind of the x-axis or so, I'm talking kind of about different energies. So absorb, hopefully think, okay, absorption line spectra. Basically, these are energies that those electrons absorb on their way up. Okay. So what happens then is we're actually going to see absorption line spectra, as we call them, I call them sometimes, I've heard them referred to as dark line spectra, i.e. dark line. And basically you're going to see kind of a nice continuous spectrum, and certain energies have been sucked up. Why? Because that's characteristic of how the electrons wanted to be or could be promoted. Okay, so they sucked up at that particular energies. Talking about emission line spectra, where the electrons are excited, they fall back down, they emit light. These are called bright line spectra. So basically, bright line spectra, you're going to see black background with these discrete energies at these wavelengths. Absorption line spectra, you're going to see, and I'll show you an example here, kind of like a rainbow or a continuous spectrum, basically, and energies absorbed. So there, that was my go for that. So here we see actually kind of an assortment of possibilities. So let's kind of orient ourselves here. Against the y-axis, against the x-axis, we see wavelength. Okay, these are different energies. Okay, we have long wavelength down here, and we have shortest wavelength up here. Okay, ultraviolet and infrared. Notice then along the y-axis we have intensity. So as you go up on the y-axis, that means it's coming very powerful at that particular energy, okay, or wavelength. So for instance, if we kind of go from left to right, can you see where these are kind of, it goes along, so, okay, energy is being emitted. These would be bright line. Okay, these would be Kirchhoff's second law right there. Okay. Let's see this right here. Okay, where you see no blips, that's a continuous spectrum, Kirchhoff's first law. And then over here, okay, notice that to me, it looks like the continuous spectrum should be kind of go from this point to this point, kind of a straight line. Well, it doesn't, it goes, okay. These are where energy is being removed, characteristic of the electrons around a particular element, and that is giving us dark lines. Okay, that is Kirchhoff's third law. Okay, then we have more continuous spectrum here, and then I don't know if you can kind of see it, but it looks like, if we call this segment C to D, it looks like it should be kind of straight, and again we see a dip down in intensity. Okay, so again, more dark lines. Okay, so what you do is you get out your little library and you kind of see what these lines could be an indication of the presence of. So these are just going to kind of talk you through. I hope all my builds are okay. Okay, a continuous spectrum. Again, it can tell us information about temperature. Okay, but there's no electrons being excited or falling down. So here is an example of an emission line spectra. Now you'll just have to kind of bear with me. Right here is a prism, or some sort of, sometimes instead of a prism it can be like what we call a diffraction grating, but just to basically kind of separate the light that's coming and kind of look for any sort of emission lines we may have. And right here we have actually, with regard to intensity, you can see the blips, blips, blips. This is a bright line or emission line, Kirchhoff's second law. Okay, and it is showing you characteristic of the elements that was in that gas. Okay, electrons are behaving according to the electrons they are in a cloud about. So moving on then to the next one. Notice that in this one, we basically have light that is trying to go from point A to point B. So right here we have a source light, and we have a cloud that is basically sucking up some energy from that light. So instead of seeing a continuous spectrum from that light, we actually see electrons that are around atoms in that cloud are absorbing energies, okay? And that's what we see. Absorption line spectra, Kirchhoff's third law.